All right, these are going to be our notes on the universal law of gravitation. So you should be on this page following along as we go through these. So let's think about some stuff that we already know about gravity. So the first thing that we want to think about is the size. So we know that really big objects like Earth, Earth has a pretty strong gravity, so it's going to pull stuff really strong. Strong gravity. But smaller objects like the moon, they aren't going to have as strong of gravity, so their force is going to be smaller gravity. So Earth pulls really strong, smaller things like the moon are going to pull weaker, and things bigger than the Earth, like the sun, will pull even stronger. So more massive objects will pull, or more massive objects equals more gravity. That's what we'll say there. Okay. Next one is distance. So we know that here on Earth, we feel a pretty strong force of gravity. So let's draw our little person standing on the edge of the Earth here. Okay. They're held in because they're really close to the Earth. But if we had an astronaut way out in space, he's not close enough for the Earth to be pulling very hard. He's going to have a very weak force here pulling him in. So for our rule for distance is closer objects feel more gravity. Okay. And let's do a quick compare here. Let's do the sun and the Earth. Okay. So the sun and the Earth have a gravitational force between them. So the Earth is being pulled towards the sun by its force of gravity. And the sun is being pulled towards the Earth by the Earth's force of gravity. Okay. We're going to come up with a rule for gravity here that might not be intuitive right away, but the amount that the sun pulls on the Earth is the same amount that the Earth pulls on the sun. And the same actually goes for you. You are pulling up on the Earth just as much as the Earth is pulling down on you. The issue is the Earth is so big compared to us that it really doesn't have any acceleration due to that force. So our rule for gravity, the force applied on one object is the same as the force applied on the other. Yeah. So that's our rule for gravity. Our units of mass, remember mass is the symbol m. We use kilograms in this class. So as we do these types of problems down below, just make sure that you're working in kilograms. So now we need to come up with an equation that we can use to calculate the force of gravity between two objects. And the equation that we are going to use is Fg, so force of gravity, pretty self-explanatory there, is equal to G m1, m2, so mass 1, mass 2, divided by the distance squared. This equation probably looks pretty familiar. If you'll think back to when we did Coulomb's law, this looked like kqq over d squared. It has the same general form as an electric force between two objects. But this time, instead of a k, we've got g, and instead of q's, we've got m's for masses. Just like in that other equation, g is a constant value. It's the universal constant for gravitation. This is going to be 6.7 times 10 to the negative 11. So G is a really easy one. This is the number you use every single time. You never have to change what this number is. Mass 1 and mass 2, those are just the masses that it gives you in whatever question that you're doing. And then d squared, we know in this class that d stands for distance. Okay. And so when it's got the squared on it, we just take whatever distance it gave us and we square it. So let's use this equation in an example down below here. We need to find the force between the Earth and a physics student. So we're going to say that the Earth has a mass of 5.9 times 10 to the 24 kilograms. The physics student has a mass of 70 kilograms, significantly smaller than the mass of the Earth, which makes sense. And the student is standing at sea level, which we're going to say is 6.38 times 10 to the 6th meters from Earth's center. So we've got all of the numbers that we need. Let's plug them into our equation. Force of gravity is equal to G, which is 6.7 times 10 to the negative 11th. Mass 1 is the mass of the Earth here, so 5.98 times 10 to the 24th. The mass of the physics student, which is 70. And we're dividing all of that by the distance squared, so 6.38 times 10 to the 6th squared. Once we've got it written out like this, all we need to do is plug it into our calculator. So I'm going to go ahead and do that real quick. Okay. And when I plug this number into my calculator, I'm getting 689.02. And remember, our units of force are newtons, so you should have an N on that end point there. Okay, so that would be our final answer here. Honestly, I feel like the trickiest part of this is figuring out how to plug this into the calculator. So that's why I use parentheses around everything to make it as easy as possible to plug in. But if you're struggling with this, find someone in your group, see if maybe they can help you with the calculator part. On the back of this page, we've got a try it on your own. So I want you guys to do what we just did on the front, just with this problem, and pause the video here, come back to check your answer afterwards. Okay, go ahead and check your answer here. Some of you might have noticed that it's basically the same problem, but instead of 6.38, we did 6.39. And so that, you can see here, changed our answer a little bit. So this time we got 686.87 newtons. So that's it for the notes part of this. There are some practice problems down below. It gives you both masses and the distance, so all you've got to do is plug those numbers into the equation to find the answers. So if you ever got confused, go ahead and go back and hear me explain through the examples again. But besides that, good luck with your work.